Patrick Cook here. So thanks for returning to session number 25 of our Mandelbulb3D Epic Rendering tutorial series. Let's pick up where we left off. And I was promising we'd talk about these tiles. Now this is where it kind of gets fun. All right. Earlier in this tutorial series, I explained what those tiles were. It's actually your whole image is divided up into a grid or a matrix where you have a certain number of tiles that are in rows, a certain number of tiles that are in columns. All right, rows and columns. All right. The reason that we're breaking up this original of 9,000, all right, is so that we can get each of these tiles rendered well within the memory limitations, the Mandelbulb3D application being a 32-bit and having more restrictions on the amount of memory that will be allocated to the application by the Windows operating system than 64-bit. Mandelbulb is not 64-bit. I highly doubt that it ever will be. That's the way it is. So what we need to do is to use this Big Render tool so that we can divide up our rendering job into tiles or segments or sections. All right. Now you notice here tile count horizontal, tile count vertical. Big question. How many tiles should you have? I mean, look, I can come in here. Let's keep in mind now our basic resolution that we're working with and also our anti-aliasing. Keep all that in mind. I could come in here. I could do. I think I once tried to see how far I could tick this up, and I think I got up around 99. I can have 99 tiles horizontally and 99 tiles vertically, and what's that? 998, something like that. I could do that. All right, and if I did that, well, if I did 10 tiles, you see here that it's doing a calculation for me, tile size, including anti-aliasing, which is down in here, which is 2. Each tile size is going to be 1,350 pixels wide and 900 pixels in depth. More. I don't need those 1350 by 900 will render easily within the memory because each tile renders individually, one at a time. Render, 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 render. All right. So that's well within my memory allocation. Well within. So the question is, do I need, in this case, 100 tiles? Given that each tile will easily render well within the memory allocation that the Mandelbulb application is able to get. And the answer is no, I don't need 100 tiles. I don't need that many. There is no gain in having more tiles. You got to keep in mind what this tiling is all about. Here's the primary objective. And I'll say it succinctly and clearly. The primary objective, or probably the only objective, of breaking a large image into tiles is so that each tile can render comfortably within the memory that can be allocated for rendering. All right. 1350 is very comfortable. Let's tick this down. Let's go all the way down to the minimum, which is 2. Okay. So here we go. We got 2 by 2. We got 4 tiles. Each tile, including anti-aliasing now, will render with at 6750 pixels by 4500 pixels. Now that will still render within the memory allocation, and we know that because we had done some renders up here and we found that we could render at 9000 by 6000. So I could render this. I could do this project here with 4 tiles. I could. But now you ask yourself the question, okay, so each tile will render comfortably, but how close am I to the memory limitation? And do you want to take the risk of Mandelbulb hitting the memory limitation and then messing up your job? So what I like to do is I like to kind of target for about half of the memory allocation that I know will render up in here. I know that 9000 by 6000 will render. So I kind of like to shoot for like half, maybe even a third of what I know will render given the memory of my machine, my PC. So I'm going to bump this up to, I'm going to say 4. Now there we go. So here's 1375, which is about 1/3 of what I know will render. And because based upon previous experiments here in the series, you know, I ticked that up to 10,000 and I got it out of memory. So I know that 9,000 is like right at where this particular PC, a particular arrangement will run out of memory. So here I'm going for about 1/3 of what I know the memory can handle. I could do half. I could do half. There's about half. I could do half. All right. A third is a third of the resolution of what I know this machine can render is very comfortable. And I also don't have a problem with, what do we got here? We got 16 tiles. I ain't got a problem with that. If I was in a situation where I wound up having to output 50 tiles, well, that's more to handle. It's more processing. It's more chances that a tile could be corrupted. And then I got a bad spot in my final, and I got to go back and fix all that. So 16 tiles for this particular scenario is comfortable. It's comfortable. I could do more, and I'm even more comfortable. I could do more tiles, and I'm even more comfortable on the memory. But now I'm starting to add a whole bunch of tiles that all have to be handled and processed and ultimately stored. All right. So let's be reasonable here. Okay, let's get to 4. If I could count, there we go. 16 tiles will render comfortably within the memory allocation. All right. So I'm liking this configuration right here. 4x4 tiles, anti-aliasing of 2. I've got some anti-aliasing, but not a whole bunch of it. I've got some headroom here. In other words, I'm over rendering this so that I got some quality adjustment headroom. Okay. Okay, so we got a minute or two left here on this session. Let me drop down to here. Save Z buffer. Oh, I talked about what the Z buffer is in tutorial series number 1, where we were doing the animation project. A Z buffer is basically it's a file that is outputted as a PNG that will hold the depth information of your scene. All right. The whiter or the lighter the area of the Z buffer image is, the closer the objects are to the camera. the darker is further away. Full white would be like right in front of you. Full black would be way off in the distance. It is the Z buffer images are a pretty cool way to be able to, in another application, such as Photoshop or GIMP or something like that, where you can use it to simulate depth of field. In other words, you could use a Z buffer image to tell the editing software to blur everything at a certain distance out, you see, or sharpen the foreground or whatever. Leaving the Z buffer on is really depends upon whether or not you're going to be using it in your application. I'm not using it. I don't need the Z buffer for my printout. I could, if I wanted to get in there and create a little bokeh, all right, but I don't need it. So I'm gonna just keep it unchecked. Now, lastly, we're over time here, but lastly, this save M3I files. What that says is that as these tiles are rendering, they're going to be not going to be saved as PNG. They're going to be saved as M3I files. Doesn't make a whole lot of sense because now you need to open those files and get the PNG image out so that you can merge them all together again. Really depends upon your application. I go right for the PNG files right here and just get them laid down on the hard drive so that I can merge them all back together again. All right, a couple more things to talk about up here, but let's save that for the next session. I'll see you in session 26. I'll see you there.